everyone, and welcome to today's lecture and a new topic. In this part of the course, we will look at graphs in a new way. So what is all this about? Well, so far we've studied graphs as abstract objects, where they consist of vertices and edges. And we've cared about such things as which vertices are adjacent to which, what kinds of subgraphs we've had, but we haven't looked at geometric properties. So for example, this graph so far we've only looked at it as a graph with four vertices that are cyclically adjacent to each other. So it's the same thing as this graph, really, if I move this vertex and bend it open down here. And these are, of course, the same graph, but now we will take a look at the geometric properties of graphs. Why is that? Well, that tells us a bit more about the graphs. It shows us some beautiful results in mathematics, and it has applications in many areas, and also it gives us a way to link together graph theory and geometry. So what is it about? The question we will ask is a geometric one. Given a graph, can we draw the graph in a plane without crossings? So a plane is like a sheet of paper. So if we look at the previous example, this graph that I just drew, we could do that. I mean, as it is now, these edges cross, but that's just because I chose a stupid way to draw the graph. If I had drawn the graph like this, then that is possible. I could bend the graph open. But maybe for some graphs this is never possible. However you bend, you will have a crossing somewhere. That is what we will investigate now. So first, we need a proper definition of this notion. And the proper notion to deal with these things is the notion of planarity. So a graph G is called planar if it can be drawn in the plane in such a way that any two edges do not intersect except at vertices where they are actually supposed to go. So vertices where they are incident. So let's look at some examples of planar graphs. So one example is the graph W5, so the wheel graph with 5 vertices. Here already, as I have drawn it, there are no intersections except at the vertices. So any drawing of a planar graph where there are no crossings is called a plane drawing of the graph. Sometimes it's also called a plane graph. So there are a few words that you shouldn't mix up. A planar graph is just a graph in general that it is possible to draw on a plane without crossing. And any such drawing is called a plane drawing or a plane graph. So the example we saw twice already, and now let's watch it a third time, is K22, the complete bipartite graph on 2 plus 2 vertices. And I told you that we could draw it in this fashion. But more generally, K2S, you can draw, so this is the graph with 2 red and 2 black vertices. So for the example of K22, I moved my red vertices like that. And for K2S, a more nifty way to draw it is like this. So you have your S black vertices on a line and the red vertices above and below, and then it looks like this. So these are planar graphs. In the previous chapter we looked at trees, and I claim that any tree is planar. We'll not prove this at the moment, but you can convince yourself that if we have a tree, we don't really have any cycles. It's at cycles that things seem to be messy, because then you can have crossing and so on. But the tree can always sort of unfold it. But that is just a heuristic argument. I haven't proved anything. But these other examples are examples of plane or planar graphs. So let's look at another example. Let's look at K4. So K4 looks like this, and as I've drawn it here, I have this red edge crossing the black edge. So this is not a plane drawing. But if I take this red edge and instead pull it out, like so, it's still the same graph. I haven't changed the adjacencies, but now I've drawn it in a different way so that I don't have any crossings. Another way to draw K4 is like that, and from that drawing you can see that in fact it is already a plane drawing. So the graph K4 is planar, and these are two plane drawings, whereas this is not a plane drawing.